Push that rock with Simpson math. Hopefully you remember the give birth to the mother, which says that if you take the derivative of e to the x, you just get back out e to the x. So we did the operation on this function, and the same function came out. And this means that the function's output tells you the slope of the curve at the given input as well. Oh, amazing. Now, the placenta rule says something very similar. You write down the mother, you give birth to the mother still, but then you multiply by the derivative of the exponent. So the derivative of x cubed by power rule is 3x squared. Now, this would be the same because the derivative of constant is 0. So again, we're going to get 3x squared, the derivative of x cubed, times the mother, x cubed. So the placenta rule says in general that if you've got e to some function up here, then it's the derivative of that function times e to the function. That's the placenta rule. Now, in this class, we're going to reverse the placenta rule. So we're anti-differentiating. So we need to know the function that we take the derivative of to get this. Well, clearly it's e to the x cubed, because if I were to take the derivative of this, I would get the e to the x cubed portion, and then I would take the derivative of this and get this portion. And then don't forget your plus c, because it could be any constant out there and it would go to 0 when you differentiate. So this is the reverse placenta rule. Let's do one more example. So the derivative of negative x cubed, if I take the derivative of a negative x squared, sorry, not x cubed, that's a square, then I would get negative 2x, okay? So there should be a negative 2x out here. Well, all I have is the x. Well, that's okay, because I can multiply by a numerical form of 1. I can say, well, I'll put a negative 1/2 out here times a negative 2, and that is a positive 1. And I will integrate that times x to the e to the negative x squared. So I'm integrating really the same thing I had before, because this is a 1, but I'll kick the negative 1/2 out. So I'm integrating negative 2x e to the negative x squared, and the reverse placenta rule applies. There's the mother, there's the derivative of the exponent, so I just get the mother. And this is sitting out here, so that's there, and then your plus c. And that's how you use the reverse placenta rule to integrate a function that has e to the function in it. Now, you have to be very careful. If I was looking at just this, well, this is impossible to integrate using our techniques of just getting out common functions. So sometimes anti-differentiation is not really possible. So it has to be just so to be able to apply the reverse placenta rule. Math made simple. Simpson math.